Yeah, we have got a topic here. We have got two spheres. One is having radius r1 and one more is having radius r2. Let's say these two spheres are initially charged. The first one is having a charge q1 and the second one sphere has a charge q2, and these charges are distributed on the surface uniformly. Now what I do? Very simple. I'm going to connect one wire between the two spheres, and that wire is made up of conductor. Now think what actually happens. Guess whether any charge distribution happens. Like, even after connecting the wire, do you think that charges on each sphere become same? Yeah, let's find out. Remember one thing, before you connect the wire, potential of the first one and potential of the second one, both are not same. And you can define potential for a given sphere. It's a spherical shape having radius r1. So potential of the first one is given by v1 is equal to 1 by 4 pi epsilon naught, a charge by radius. And definitely can do the same for the second one. And since radius and amount of charge distribution are different, definitely potential may not be same. If potential is not same, then charges will have to flow from the sphere number 1 or maybe from the sphere number 2 to another sphere, and depending on which is higher potential, which is lower potential. And this flow of charges, or I can say a redistribution of charges, happen until both the spheres would get same amount of potential. Let's say this is sphere number 1, let's say this is sphere number 2, and the first sphere having a radius r1 and second sphere having a radius r2, and definitely after connecting this wire, both of the spheres will give same potential. That means the potential of the first one will be equal to potential of the second one. And what about the charges? Definitely charges will be redistributed, and it won't be same q1, definitely it will be something new. So let's say that charge is q1 dash, and the amount of charges on the second sphere is q2 dash. And what about the radius? Radius doesn't change at all, and it's the same sphere we are having. So we'll go for this argument, and my question is simple. How much is this q1 dash? Can we write this q1 dash in terms of the size of the sphere? There is r1 and r2, and even in terms of the charge which we had before, that is q1 and q2. Yes, we can try. Now what we have to do is just go for this condition. Potential after you connect the wire, potential of each sphere becomes same. So if I just start writing the equation, so 1 by 4 pi epsilon naught, the charge on the sphere number 1 is q1 dash. Now this is a new charge by radius r1 is equal to 1 by 4 pi epsilon naught q2 dash by r2. Now all you have got is q2 dash by r2 is equal to q1 dash by r1. I can write for q2 dash. q2 dash is equal to q1 dash into r2 by r1. Let's say this is the equation number 1. Now even I can just follow the conservation of charge, law of conservation of charge. Before connecting this wire and after connecting the wire, the total charge on the system of two spheres must be same. There won't be any loss of charges. So what I mean to say, it's simple. So sum of the charges before, that is q1 plus q2 in two spheres, is equal to sum of the charges after, that is q1 dash plus q2 dash. So let's do one thing. Let's substitute for q2 dash from equation number 1. So this will be q1 dash plus q2 dash is q1 dash into r2 by r1. And I can just take q1 dash common, 1 plus r2 by r1, which is equal to q1 plus q2. I want to write for q1 dash. I want to know how much amount of charge that can store in sphere number 1 after you connect a metallic wire between the two spheres. And I want q1 dash. So q1 dash is equal to q1 plus q2 into, so r1 by r1 plus r2. So this is the final expression for the amount of charges that can stay in the first sphere after connecting the metallic wire between the two spheres. And similarly, if you do the derivation same, you can write even for q2 dash, and q2 dash is equal to q1 plus q2 into r2 by r1 plus r2. So definitely this q1 plus q2, whatever we have got, this is nothing but sum of the charges before. So total amount of charge that you have given to both the spheres is nothing but q1 plus q2. Now imagine there is a case where two spheres are similar, If two spheres are similar, then definitely R1 is equal to R2. Size of both spheres must be same. If that is the case, then you can write Q1 dash is equal to total charge, that is Q1 plus Q2. This will be R plus R. R by R plus R is 1 by 2. So this will be the new charge. And even the second sphere Q2 dash is equal to Q1 plus Q2 by 2. So that's it. Hope this helps you.